All right, so what type of equation is this one? Exponential, thank you, Hannah. Okay, so what did we do with the exponentials?
Turn them into a log.
We turn them into logs, right? And then the log ones we turn into exponentials. Eaten. Put it away for a little bit. So when we take the log of both sides, we just put log in front of both. And again, some of you do start a little bit different as far as putting this in front right away. But since we're taking logs, we can take this exponent out front and multiply it by the log. That's the same as having it as the exponent. So this is the way we should do these. That way we don't have to try to think, can I write 10 and 315 with the same base? Which probably can't happen. Okay? So what we're going to do then is take this log of 10, the one on the left, over to the one on the right. Since this is multiplication here, I'm going to do division. Take it to the other side. So that cancels there. And then this problem here on the right, I'm just going to do in my calculator. Okay. And we always just do the base 10 log. If you wanted to, you could do the natural log. You could hit the LN button if you wanted. You'll still get the same answer. Okay, but I always just do the log. So I go log of 315. Just remember to close it off. I still think there's a few of you that are forgetting that. And it's divided by log of 10. And that's 2.49, 2.5. Let's just round it to 2.5. And then from there, it's real easy. Subtract 3 and divide by 2. So that's negative 0.5, right? I believe. And then divide by 2, that'd be negative 0.25. Now let's see if that works. A lot of times a negative answer doesn't work. So negative 0.25, let's see if that works. Maybe I did something wrong there. 10 to, oops, back up, to the 2 times negative 0.25. That's not going to work. Gotta do this. Need to put it in parentheses. Plus 3. Again, I rounded that. It should be, I did some rounding, so it might not be quite 315. Let's see. Yeah, it's a little bit more because I rounded it. Okay? If I wouldn't have done any rounding, we'd work it out. Okay? So the negative is okay in that situation. We weren't taking logs, so. So it should work. But it's good to check. All right, so that was the one thing we did. The other type we'll do here, going over a couple answers. There's a couple of them towards the end, you guys. Those of you that did work on your homework kind of left blank at the end, so we'll go over a couple of those. Number 3, you should have gotten negative 1.5 or negative 3/2. Number 6 is 5/4, which is 1.25. And number 9 is 2.64. And number 12 is negative 2.13. questions on 3, 6, 9, or 12? You did the wrong one, Simon. You started at number 4 for some reason. Okay, we're okay with those. I would like to look at number 15 because it's got the E in it. All right. So it's E to the X power is 10. Okay, so instead of taking the log of both sides, since it's E as the base, I'm going to take the natural log of both sides. Okay? Because what happens if I have natural log of E? What is that? Come on, we don't need a calculator for that. They cancel, right? So what things cancel, what answer is that? 1, right? And if you want to, actually do that in your calculator, you hit natural log, and then E is this second division. You'll see that it's 1. But they just cancel. So that's why I used that natural log this time. Log will still work, but that just gets that out of there. So I just got X equals, and then I just put in my calculator natural log of 10. So it's 2.3 for number 15. Okay, so when you see that E in there, to get rid of it real quick, just take the natural log of it, they cancel each other out. Then whatever the exponent is the answer.
Any closer to these students that come with me?
It's the same one. Yeah. Brandon, they need you to go with them. All right. 18 is negative, I think that's a 2.14. Right, it was that. Might have been a negative 3 point, actually. 21 is 7. 24 has 2 answers. Negative 5 halves and 6, or negative 2.5 and 6. Those both work. And 27 was 2.09, and 30 was negative 5. All right, 27 I'd like to look at because we didn't do one like that. And some of you, like beers, wimped out when you saw it. It got a little tougher. But at least he was trying, right, Jacob? What? At least he was trying to do this, probably. At least he wrote it out, I guess. I don't know how hard he tried. How hard did you try, Matt?
I don't want some random answers.
Yeah, I thought.
I think it's
Now, then he would have had all the right answers. And he didn't. So at least he's trying. Okay. So we didn't have one like this yesterday. If we had a log on each side, we didn't have an extra number with it. If this 2 wasn't there, what could I do to both sides? Just drop the logs, right? If you have log of something equals log of something, those 2 somethings are equal. You just drop the log. Okay? But since I have this number 2 here, what I need to do is bring this log over with this one so that I can condense it into a single log. So how do I move the log on the right over to the one on the left? Gotta subtract it now. It's addition, so I do subtraction. So that those cancel. So all I got left over here is a 2. And then how do do we do subtraction of logs to condense it? What do I do with the two numbers? Divide them, right? So this will be log of 5x minus 1 over x minus 2. So now that's the problem. We have a single log on the left equals the number 2. So, Connor, this number equals what when I change it to exponential? This is exactly like the one I got after you yesterday.
I don't know.
You don't remember. After I got after you yesterday, I figured it would sink into that melon of yours.
Do I have to take the log of both sides?
No.
Alright, I'm not sure.
What's the base of that log?
X minus 2.
No.
5x minus 1.
No. We did the same thing
I
yesterday.
don't know. No.
If there's no number written here, what's the base?
I don't know.
Everybody else?
I don't know.
10. Even Eaton knows that. He doesn't know a whole lot. Unless he wants to. All right. So if the base is 10, Mr. Sturmey, what's the other side? What's that number equal, this fraction? If this base is 10, what's on this side? 10. Nathan, can you help everybody? No. No. Baluch. 10 squared, is that what you said? Yeah, you're correct.
Well, I got half.
You got half of it, huh? All right, remember, if I have a log equal a number, the base of the log to that power equals the number. Changing it from log form to exponential. That's something we're supposed to know how to do by now. All of us are supposed to know by now. All right, what is 10 squared? 100. What am I going to do to move this x minus 2 to solve this? Can't leave that in the bottom. Multiply, right? We had a problem very similar to this one yesterday once we got to this point. All right, the x minus 2's cancel. So I have the 5x minus 1. Then you got to distribute 100x minus 200. And then just finish it up. So I want to take the 5 to the right so I don't get a negative x. I'm going to take the 200 to the left. So the 5s go ahead way, negative 1 and 200 is 199. I got an extra equals in there. Why did I do that? All right, and then those 200s cancel. 100 minus 5 is 95. And just divide by 95. So I don't think that reduces. If you want to find out what the fraction is, you can. I'm sorry, decimal. 2.1 if we round it. So that's number, what was that? 27. Okay, so that was a little different than what we had. You know, I didn't give you an example with a log and a number. Okay. The last one, 30, I just want to go over that one with you as well. Because it comes out to be a quadratic. I just want to review how to solve a quadratic with you. So I have a single log on the left, log of 4 minus x. No number, so the base is 10 again, right, Connor? And I have addition of 2 logs. Which is x plus 8. And 2x plus 1, no? 2x plus 13. So the one on the right, I'm going to condense. Since it's addition, I can make it multiplying those two things, x plus 8 and 2x plus 13. So what we say, if we have the log of something equals the log of something, what can we do with the logs? Just drop them, right? So I got 4 minus x on the left. And then I'm going to go ahead and FOIL this. X times 2x is 2x squared. X times 13 is 13x. 8 times 2x is 16x. And 8 times 13 is, what's that, 104? Did I do that right? Okay, since it's a quadratic, I've got to set it equal to 0. So I'm going to take the 4 and the x over to this side. So I got my 0, my 2x squared. 13 and 16 is 29, and 1 is 30 for the x. And 104 minus 4 is 100. Okay. If I might be able to factor this. I'm going to take a 2 out to GCF. That is, what are the factors of 50 that add up to 15? I heard somebody. 5 and 10, thanks. 5 times 10 is 50, 5 plus 10 is 15. So my two answers are -5 and -10, but I pulled the 2 out, so I think I got to divide by 2 on the, well, maybe not. No, I don't think I do. Let's see which ones work. If I have a -5, what's 4 minus a -5? 9, so that's a positive, that's okay. -5 plus 8 is 3, that's still positive, that's okay. -10 plus 13, that's 3, so that -5 works. If I use -10, I get 14 here, 4 minus -10. -10 plus 8 is a -2, that gets that one out of it. So the only one that works is a -5. Because again, you can't take the log of a negative. So, log equations, we try to get a single log equal to a number. Then whatever the base is here, we take to that power, set that number equal to it to solve it. Turn it into an exponential. Okay? On the exponentials, we take the log of both sides. Take the exponent out front, divide the log on the left, move it over, and then end up finishing. All right, so exponentials we turn into logs. All right? Okay, so that's all for today. You got a practice quiz for homework. We'll go over it tomorrow. Your quiz will be Thursday.